Somewhere in our galaxy right now, there's a place where the laws of physics just stop. They don't bend, they don't weaken, they literally just stop working. Welcome to This Explainer. Today, we're taking a deep dive into the absolute darkest, most extreme environments in the entire cosmos. We're going to explore what actually happens when something crosses the edge of a black hole. It's a journey full of stretched light, frozen time, and physics so mind-bending it's going to completely change how you view reality.
So let's really think about this. What actually happens when physics simply stops? At the very heart of every single black hole sits something called a singularity. It's the ultimate cosmic mystery. But here's the wild, totally counterintuitive part. If you were to actually fall into a black hole toward that singularity, you might not even notice anything weird at first. Seriously. You wouldn't hit a wall, you wouldn't feel some crazy jolt, you'd just keep falling and falling and falling until reality itself literally came apart around you.
All right, let's jump right into Section 1, the object that shouldn't exist.
To really wrap our heads around the terror and the wonder of these things, we kind of have to understand how we even know they're out there lurking in the dark. Picture this. It's 1915, and Albert Einstein publishes his theory of general relativity. It beautifully described gravity not just as a force, but as an actual curve in the fabric of space and time. But then, just months later, a German physicist named Karl Schwarzschild was serving on the Russian front during World War I. Right in the middle of all that horror, he actually solved Einstein's equations. And what he found was, frankly, disturbing. His math proved that if you pack enough mass into a tiny enough space, gravity gets so incredibly strong that absolutely nothing, not even light, can escape. Now the crazy part? Einstein himself flat out refused to believe it. He thought it was just some mathematical glitch, convinced nature would never let something so ridiculous actually form. But, well, decades of evidence proved him totally wrong. And it all culminated in 2019 when the Event Horizon Telescope took the very first actual photograph of one.
And that brings us to an absolutely staggering realization. 4 million. That's a huge number, right? Let me put that into perspective. There's probably a black hole sitting at the center of nearly every galaxy out there, including our very own Milky Way. So right now, as we speak, a supermassive black hole, 4 million times heavier than our sun, is quietly anchoring hundreds of billions of stars in orbit around it, right in our own cosmic backyard. Moving on to Section 2, the point of no return.
I want you to imagine for a second that you're in a spacecraft, engines firing, charting a course directly toward that dark center. We're taking that journey together right now. As you get closer, you hit its boundary. This is the famous Event Horizon. You can think of it like a one-way door in the universe. Outside this horizon, you're fine. You can still escape if you blast your thrusters with enough speed, but the second you cross it, no way. No amount of power in the entire universe can bring you back out. The really crucial thing to grasp here is that it's not a physical surface. It's not a wall your spaceship is going to crash into. It's simply the exact distance at which gravity has bent space so severely that every single possible path, even the path that light takes, leads only inward.
And here's the part that totally breaks most people's intuition. If this black hole is big enough, crossing that event horizon would feel like nothing. Literally nothing at all. There's no flash of light, no physical barrier, no alarm bells ringing in your ship. You just sail right through, perfectly smooth. You could even look out your window back at the stars behind you and they'd still be shining. Except now, unknown to you in that quiet, peaceful moment, there's no physical path back to them. The universe you just left behind is permanently, officially out of reach.
Which brings us to Section 3, a tale of two realities.
Because right as you're crossing that silent threshold, something genuinely bizarre is happening. If we look at the two perspectives here, it's mind-blowing. For you, the falling astronaut over on the left, reality feels perfectly normal. You just cross the horizon smoothly and keep falling inward. But for an observer, let's say a friend watching you from a safe distance in a mothership on the right, that extreme gravity is actually stretching time itself. From your friend's perspective, they would never actually see you cross the threshold. To them, you'd appear to move slower and slower. Your image would grow dimmer, stretching into the red end of the light spectrum, until you essentially just freeze at the edge of the black hole forever. Your friend outside and you inside are experiencing two completely different, conflicting realities of the exact same event.
I know, it sounds like something straight out of a sci-fi blockbuster, but I need to ground us in the facts here. This isn't science fiction. This literal split in reality is a direct, tested consequence of general relativity. It's been confirmed by decades of rigorous astronomical observation. It is just a fundamental, if totally weird, truth of the universe we live in.
Let's move into Section 4, the singularity.
Let's just slow down for a second here. You've crossed the horizon. You're completely cut off from the universe, just drifting toward the very center. Once you're past that event horizon, every possible direction you turn, every single path you could possibly take, leads inevitably to one final destination, the singularity. This is the eerie, totally silent heart of the darkness. It's a point where gravity literally becomes infinite, a point of zero size. It's the place where space and time, at least the way we understand them, completely and utterly collapse.
But wait, what does infinite gravity even mean? Well, most physicists agree that nature isn't actually creating true infinity here. Actually, when our math tells us gravity is infinite, what it's really telling us is much simpler. Our equations have broken down. Our current understanding of physics is failing us. It's arguably the biggest open problem in all of science right now. To understand what really happens in that tiny, zero-size point, we need a whole new theory, one that somehow perfectly unifies gravity with the funky rules of quantum mechanics. Whoever finally figures out that missing piece, yeah, they're going to fundamentally change our understanding of reality itself.
Okay, let's snap back to practical reality for a minute. Section 5. Would you survive?
We've talked a lot about the weird physics and bending time, but what would actually happen to a human body in this kind of extreme environment? Well, it entirely depends on the size of the black hole. If you fall into a typical stellar black hole, one made by a single dying star, the answer is brutally simple. No, you absolutely will not survive. As you get closer to the center, the gravitational pull on your feet becomes millions of times stronger than the pull on your head. The difference is so extreme that you'd be stretched out into a long, incredibly thin strand of matter. Physicists genuinely, officially call this process spaghettification. It's a pretty visceral, horrifying way to go. But if you fall into a supermassive black hole, the ones with millions of times the mass of our sun, the math totally changes. Because they're so huge, their event horizons are located incredibly far away from the crushing, tidal forces of that singularity. You could cross the horizon of a supermassive black hole totally smoothly, and for a good while, you wouldn't feel stretched at all. You'd survive the crossing perfectly intact. You just wouldn't be able to tell anyone about it, and you could never, ever go back.
Black holes are really the ultimate reminder of one simple truth. The universe, frankly, doesn't owe us intuition. The fact that an object can be simultaneously frozen in time to one person while falling at the speed of light to another, depending entirely on where they happen to be standing, is just mind-boggling. They represent the absolute edge of reality, a place where our very best scientific theories just have to throw their hands up and admit they don't have all the answers yet. Which leaves us with one final kind of haunting question. Is there one silently waiting near you? The universe is unimaginably vast and dark, and remember, these objects don't emit any light of their own. There could very well be a black hole within just a few thousand light years of exactly where you're sitting right now, just silently bending the space around it, waiting in the dark for the next unlucky piece of matter to cross its horizon. Think about that the next time you look up at the night sky.